Hello and welcome to my video about Ethernet trunking. In this video we're going to explain the connection requirements for multiple VLANs, the IEEE 802.1q trunk, the native VLAN, and trunking to a router or router on a stick. So from previous videos on VLANs we learned that we can isolate traffic on a switch by creating VLANs, but this method requires a lot of cabling. Connections from switches to other switches or routers require one connection per VLAN. As you can look here, I can connect the red PC to the green PC, but what happens now is the traffic from the red PC goes to the switch and it can only be sent out other switch ports on that same VLAN. So it'll send it up to the router, and then the router is going to look at the IP information and send it out a different interface connected to a different VLAN on the switch, VLAN 20, and then it'll finally get to the PC. But this requires a lot of cabling. As we expand our network or create additional VLANs, we need one connection per VLAN per device. So by adding another switch, we've just added 2 more connections. If we add a third VLAN, now we have 6 connections required between the devices. So what we're going to be doing with an 802.1q VLAN is we're going to combine all of those VLANs across one link. But the problem we have with that is what happens here. It goes from switch 1 to switch 2. How does switch 2 know what VLAN it's on? Remember, the VLAN is something on the switch, but it's not in the Ethernet frame. It's just an assignment. It's a rule that the switch says I'm only going to forward traffic out a switch port if it's on the same VLAN as the ingress port. So if I send it out here, switch 2 has no way of knowing what VLAN that frame is intended for. If we examine the 802.3 Ethernet frame details, we see that it has a preamble, destination address, source address, type, data, and frame checksum. Nowhere in here is anything about the VLAN ID, so switch 2 has no way of knowing what VLAN an incoming frame is intended for. Thus, the IEEE got together and they created the 802.1q trunk Ethernet frame. And in this frame, they inserted a small field right here with the 802.1q tag. And inside the tag you have the priority code point and the drop eligibility indicator. This is for quality of service and congestion mechanisms. But the important thing we see now is we have a VLAN ID. Now we have a way of identifying what VLAN a frame came in on, so when the receiving switch receives it, it knows to only send that frame out ports on that VLAN. So now in this example we'll see a frame originated by PCA. As it goes across the switch and it goes over to switch 2, it's going to put that tag in there, and now it's an 802.1q frame. So now we can send any VLAN across one single connection, and we'll put that tag in there, so when switch 2 sees it, it knows to only send that frame out ports on VLAN 10. When the IEEE created the 802.1q trunk frame format, they had to make sure that it was backwards compatible with layer 1 hubs. And if you remember what a hub does, it doesn't really process anything. All it does is receive the data and flood it out all active ports. So in this example we see how you can have a PC connected to a hub, and now we're going to see what happens where we get 802.3 frames going into a hub, and now that frame gets processed and forwarded out all ports, and now we have a situation where we have switches receiving an 802.3 frame on an 802.1q trunk. So the switch doesn't have a VLAN tag on it. It doesn't know what VLAN that's intended for. So what it's going to do is treat that as if it was on the native VLAN. So by default the native VLAN is VLAN 1. You can change it. It's best practice to change it. But in this example we're going to see how switch 2 is the only one that's going to forward the frame because it's got an active port in VLAN 1. Now, how do we deal with routers? Because routers are layer 3 devices. They're traditionally Ethernet, and this looks like a host port normally. But if we tell the router to expect a trunk, then the router can handle Ethernet trunking frames. So in order to do this, we have to create subinterfaces. And the Cisco command for that is just specify the interface ID and add a decimal point, and then it's the subinterface ID. Generally, most people are going to match the subinterface ID with the VLAN number, but that's not a requirement. The next step is we're going to declare that that subinterface is going to use 802.1q encapsulation and tell it what VLAN it's part of. And the command for that, once you're in the subinterface config mode, is encapsulation.1q followed by the VLAN ID. And the last thing we need to do is give each subinterface an IP address. And the command for that is, once you're in subinterface config mode, IP address followed by the address and the subnet mask. And here you'll see the complete configuration for configuring subinterfaces. Notice in the physical interface, there's no IP address. We do have to issue no shut to turn the physical interface on. And the subinterfaces, we create the subinterface with the subinterface and the ID. And notice here on this one you can see that we have to add the keyword native at the end of it so the router knows which VLAN is the native VLAN. Now that we've learned about 802.1q Ethernet trunking, let's take a look at this in a lab environment. So I've gone ahead and created this lab scenario similar to the slides. We have VLAN 10 on both switches as well as VLAN 20 on both switches. And I put a hub in here so we can take a look at what happens with untagged traffic on native VLAN 1. So let's get started. So on PC 10 I'm going to go ahead and I'm going to try to ping PC 11 at 192.168.10.11. And the first thing it's going to have to do is send that ARP broadcast. So let's take a look. The ARP broadcast is going to come into switch 1. And if I look at the PDU on switch 1, I can see it is indeed an ARP request. It's an Ethernet broadcast address. And the inbound PDU has no 802.1q tag in between the source and the type field. If I look at the outbound PDU, I can see that in between the source and the type field, I do indeed have the 802.1q tag information. And notice here, the ID is hexadecimal, that's the 0x, and then 00A, the A represents 10 in hexadecimal code. So let's take a look and see how this progresses. It's going to get sent out all ports with VLAN 10, including this trunk that I've created over here with the router configuration. And it's also going to get broadcast out the hub, because that's what hubs do. They just take a copy of everything and forward it out all active ports. But when it gets to the switch is going to come in and it's going to receive that 802.1q tag right there. But the outbound PDU does not have that. It's only going to take that, it's going to read that tag and say only forward that out ports on VLAN 10. So it's going to send it to PC 11, and then of course PC 11 is going to send its response back all the way back through the hub, 802.1q frame here, and then switch 1 is going to receive it as an 802.1q frame. The outbound PDU will be a standard Ethernet frame. So now let's take a look at what happens when PC 30 sends an ARP request to PC 31. So I've got it queued up already, and it's going to send that ping. And the first thing it's got to do is create that ARP request, and it's going to send an 802.3 Ethernet frame into the hub. Inbound PDU, nothing in here, it's an Ethernet frame. And then the next step is we'll send that. The hub's going to send a copy of it everywhere. And now when it comes into the switch, we can see that the inbound PDU is a standard Ethernet frame, and the outbound PDU, a standard Ethernet frame again. So the switch is going to take this and say, okay, that's untagged, so I'm only going to flood it out ports on my native VLAN, which is Fast Ethernet 24 over here on VLAN 1. And then of course PC 31 is going to receive it, send the ARP response back. Notice the ARP response that went to R1 got dropped because R1 doesn't have that IP address, and it will go back through the hub. Of course the hub's going to make a copy of everything. So anyways, I hope that explained 802.1q Ethernet trunking as well as the native VLAN. I hope you found this video helpful. If you enjoyed this video, please remember to like and subscribe, and thanks for watching.